The previous video was simplifying rational expressions, so if you haven't watched that video, make sure you watch simplifying rational expressions before we begin multiplying and dividing rational expressions. We're going to be multiplying and dividing algebraic rational expressions, but let's just connect this to something that we already know how to do, like 3/5 times 7/9. In order to multiply fractions, you simply multiply across the numerator or multiply straight across the denominator. So you have 3 times 7 over 5 times 9. Now this step is not necessary for numeric fractions, but it's going to be important to recognize that we're actually doing this with algebraic fractions. We're just making the product of two different fractions one fraction. It's exactly what we're going to be doing with algebraic fractions. And then it just boils down to simplifying algebraic expressions, rational expressions, which was the last video. So here what we can do, we can either multiply the 3 and a 7 and 5 and 9, or we can cancel the 3 and a 9. So I will provide some parallel examples and do it both ways. 7 times 3 is 21, and 5 times 9 is 45. We have a common factor of 3 for both of these. 21 divided by 3 is 7, and 45 divided by 3 is 15. Or what we could have done, we could have canceled the 3 with the 9, leaving us with a 7 in the numerator and a 5 times 3, which is 15 in the denominator. So that's just proof that you can simplify before multiplying across, which I would encourage because you can see it saves a step here. Now let's go to an algebraic example. Let's say we had something like x squared minus 36 over x squared plus 8x plus 12, and let's multiply that by x minus 2 over x squared minus 6x. Now we can't just make this one fraction yet, because up here what we didn't do, we didn't factor it completely because we had numeric fractions. If we're working with algebraic fractions, you should really factor everything first before making it one large fraction. And that's going to be pretty much the procedure. Factor, make one fraction, cancel, simplify. So let's factor x squared minus 36. That's the difference, two squares, x plus 6, x minus 6, over, and the factors of 12 that add to 8 are 6 and 2. And x minus 2 is already factored. And the GCF of x squared and negative 6x is x times x minus 6. Now, for all intents and purposes, what we're going to do here is just make this one large fraction. Okay, so you see what we did up here. We had 3 times 7, we just made it in the numerator. We had 5 times 9, we just put it in the denominator. We're going to do the same thing here. So I'm just going to extend this fraction line and make this one large fraction. So now we can begin simplifying because we have a product across the numerator and a product across the denominator. In other words, there's no plus or minus sign separating any of my terms. If there were plus or minus signs, I would not be able to cancel yet. But in this case, we have multiplication, so we can begin looking for things to cancel. And this is the fun part. But be neat the way you cancel, because if you're not going to see what you have left. So there's nothing left in the numerator. That doesn't mean 0, that means 1. And make sure the 1 is in the numerator. And we have an x in the denominator. So make sure x is in the denominator. And that was a cool question because a lot canceled out. Let's do another example, but now let's work on dividing fractions. Let's say we had 2x minus 8 over x squared plus x minus 12 divided by 20 minus 5x over 2x squared minus 5x minus 3. Alright, the only difference between multiplying and dividing fractions is that you change a dividing into a multiplying. And the way you do that, keep, change, and flip. Keep this fraction the same, change this to multiplication, and flip the second fraction. So let's just rewrite this before we begin factoring. And in the future, you'll probably be able to factor this and flip within the same step, but I would encourage you to leave it alone while you change it to a multiplication question. For now. So there we go. Now we have a multiplication question. So now it's the same thing as over here. We're going to factor everything, and then we're going to look for things to cancel. So the GCF of 2 and negative 8 is 2, which leaves us with x minus 4. Let's factor x squared plus x minus 12. That's factors of negative 12 that add to positive 1. And that's x plus 4 times x minus 3 times. Now, this trinomial is going to require the payback method to factor. So I'm going to go to a piece of scrap paper, and I'm going to factor 2x squared minus 5x minus 3 somewhere else. Okay, the reason we're using the payback method is because there's a coefficient of x squared, and it's not a common factor. So now let's write our fake trinomial, factor it normally. Factors of negative 6 that add to negative 5. That's x minus 6 and x plus 1. So let's divide by our borrowed number. X minus 3, remaining denominator goes in front. Okay, so now we know the factors of 2x squared minus 5x minus 3 are x minus 3 and 2x plus 1. And 2x plus 1. Okay, finally we have to factor 20 minus 5x, and that has a GCF of 5. We're left with 4 minus x. Okay, so now we can start looking for things to cancel on the opposite sides of the fraction. Okay, so I have an x minus 3 to cancel with an x minus 3. Now this one looks like we can cancel it. This is x minus 4, and this is 4 minus x. But subtraction is not commutative. I cannot change the order without changing the difference. So these are not identical terms, but they can cancel to become a negative. So when subtraction is flipped, make one of them a negative when you cross them out. Either the numerator or the denominator, but not both. Just put one negative there. Okay, so that's all we can cancel. On the top, we have a negative 2. Remember, everything's being multiplied. That's not 2 minus. That's 2 times negative 1. Times 2x plus 1 over 5 times x plus 4. So let's work on a mixed operation question. Let's say we had x squared minus 9. Oh, drop the paper. Over x squared minus 5x times 5x minus x squared over x squared minus x minus 12 divided by x minus 4 x squared minus 8x plus 16. Alright, so now we have 3 fractions here. Let's factor everything, but before we do that, let's flip this last fraction and change this to multiplication. And then we're just going to have a whole bunch of terms to factor and cancel. So x squared minus 9, x squared minus 5x, times 5x minus x squared. I'm just rewriting these terms and then changing that to multiplication. Keep, change, flip. Okay? So now we can begin factoring all of our terms. X squared minus 9 is the difference of 2 squares. GCF of x, GCF of x, leaving us with 5 minus x. Factors of negative 12 that add to negative 1. That's x minus 4 and x plus 3. And finally, factors of positive 16 that add to negative 8. That's x minus 4 and x minus 4. So now I'm just looking for things to cross out now. Cross out the x with the x. Notice how I cross that out vertically, because if I cross it out at an angle, it's going to look like part of the x. So just be careful how you cross things out. I have an x minus 4 and an x minus 4. I have an x plus 3 and an x plus 3. Notice how I'm only canceling across the fraction lines. And notice how I cancel this term with this term over here. That's okay, because this is really like one large fraction. I have a 5 minus x. Subtraction's flipped. I'm thinking negative, so if I have an x minus 5, I can cancel it, but put a negative in there. I do. Cross it out. But make sure you remember you have a negative somewhere. I have an x minus 4 with an x minus 4, and I think that's all I can cancel. What's left in the numerator? A negative x minus 3. What's left in the denominator? 1. So you can write over 1, but they're equivalent terms. Okay, long video, but this is a skill that typically students have a little trouble with, so I needed to provide some examples. But just to summarize what happened here, to multiply and divide, if it's division, change the fraction. So if it's multiplication, then you can begin factoring completely. Then you make it one fraction. Then you can cancel identical terms. A negative if subtraction flips. Then you simplify, and that's it. Step 1, do you have division? If so, change to multiplication. Step 2, factor everything completely, creating one large fraction. Look for terms to cancel. Careful with the negative if subtractions flip. And then simplify if possible. And then tomorrow we'll add and subtract some fractions.